Good morning, everyone. I am a first-year PhD student in biodiversity, a national PhD hosted by University of Bari and University of Palermo in Italy. And also for me, this is my first oral communication ever, but also first conference, international conference ever, so thanks for the opportunity. Today, I will present a comparative study in Italian coastal lagoons about Syngnathid assemblages using a standardized sampling design that allows cross-systems comparison and also focusing on how habitat structure influence their presence and their abundance. So, Syngnathids are iconic coastal fishes that are strictly dependent on structured vegetated habitats. And despite their ecological relevance until recent days, more than half of European species were considered as data deficient, meaning a lack of quantitative information on their distribution and abundance. Yesterday I discovered that there are no more European Synggnathids listed as data deficient, so that's a great achievement. This gap is critical also in transitional coastal systems, such as coastal lagoons. Mediterranean lagoons are shallow and highly productive systems that function as key nursery habitats, but they are also characterized by a strong environmental heterogeneity and exposure to human pressures. Within these systems, Synggnathids shows a tight link to the habitat structure because of their features. So their limited mobility, their close association with vegetated beds make them particularly sensitive to habitat degradation, and that's why they are increasingly used as indicator taxa in shallow coastal ecosystems. So, despite their ecological relevance and vulnerability, many Italian coastal lagoons remain poorly studied. So, available studies are often lagoon-specific. Much of them are in Venice Lagoon, and based on heterogeneous sampling and short term. So, as a result, there is still no coherent national baseline describing Syngnathids' occurrence and the distribution, and which are the factors that shape their presence in the lagoons. So, Italian lagoons are widespread and environmentally diverse, spanning from polyhaline to hypersaline regimes, and ranging from well-protected areas to heavily exploited systems. Of course, this heterogeneity prevents meaningful cross-systems comparison, and that's why a unified and standardized sampling design is required to establish a robust ecological baseline for conservation of these species. So this study provides a baseline assessment on Syngnathid distribution and assemblage structure in 8 Italian coastal lagoons using a standardized habitat-focused sampling design. Our research focused on 4 main questions: the spatial distribution and the co-occurrence of Syngnathid species across lagoons, the relationship between assemblages and vegetation continuity, the influence of anthropogenic pressures on assemblages, and whether richness or density follow a latitudinal pattern or are driven by site-specific conditions and local environmental conditions. So we surveyed these 8 lagoons, spanning from along a broad latitudinal gradient, spanning from the northern Adriatic Sea with the Chioggia Lagoon to the southern Ionian and Tyrrhenian Sea. Site selection targeted shallow vegetated soft bottom habitats suitable for our sampling, and the chosen sites differ in local environmental conditions, for example in salinity, but also in anthropogenic pressures and vegetation patterns. So Synggnathids were collected using a beach seine deployed from shore. At each site, 4 replicates were conducted, covering parallel from the shoreline and covering a total standardized area of about 1,000 meters square. Vegetation, submerged vegetation coverage was used as a proxy of habitat, indicator of habitat structural complexity. So vegetation continuity was classified into was divided into three classes based on the proportion of the seabed covered by the macrophyte. So we have sparse, patchy, and continuous coverage, and environmental variables were also measured. Regarding to the human pressures on these lagoons, we try to estimate these pressures by creating an index, an anthropogenic index that considers four disturbances: the aquaculture, so presence and intensity of fish farming or shellfish farming, boat traffic, visible pollution indicators, and the presence of artificial substrates. Each component was scored from 0 to 1, and considering a radius of 200 meters from the sampling site, and this for each sampling station. So overall, a total of 647 pipe fishes were collected, were spotted, belonging to 4 species. The Syngnathus abaster was the most abundant, followed by Syngnathus stifle, Nerophis ophidion, and Syngnathus tenionotus. And Syngnathus abaster was also the most widespread, occurring in 7 of 8 lagoons. While Syngnathus stifle was nearly as widespread as Syngnathus abaster, despite the lower abundance. He occurred in 6 of 8 lagoons. Nerophis ophidion in 2 lagoons, while Syngnathus tenionotus was detected only in 1 site, that is Varano. It is in Apulia, this one. So, the species richness ranged from 1 to 4. Varano was the single site with all 4 species. Here, no single species accounted for more than a half of local assemblage, meaning a high degree of evenness. Then we have other sites, mono or monospecific, or with 2 or 3 species. So total densities ranged between less than 1 and more than 20 individuals per 100 meters square. Regarding the influence of latitude on assemblages, this bubble plot shows that there is no clear latitude pattern. So we have here density and richness. Regarding to the effect of human pressures, there is an evidence that highest densities occur at intermediate values of anthropogenic pressure index, while lower and both extremes. Total density varied also along the 3 continuity classes of vegetation. So we had highest values of density in continuous vegetation, lowest in sparse vegetation, and the single site, that is Marsala, with classified as patchy, had intermediate values of density. So overall, its pipe fishes occurred in all lagoons that we surveyed, but assemblages show the marked spatial variability, with density varying about 60-fold times across sites. Vegetation continuity emerged as the primary driver of assemblages, of density assemblages, and this is in line with the ecological role of canopies, of course, by providing food, refuge, and creating suitable hydrodynamical conditions. In contrast, there was a weak nonlinear correlation with anthropogenic pressures, and this suggests that maybe human influence acts indirectly on the assemblages. And there was no latitudinal pattern, so assemblages were driven by local conditions rather than latitude. Syngnathus abaster dominated most lagoons, So reflecting its broad ecological tolerance and also ability to persist under a wide range of conditions. But several lagoons hosted multi-specific assemblages, for example Varano, as I showed you before, and this suggests that Italian coastal lagoons under the right suitable conditions can host multi-assemblages of Syngnathids. And the occurrence of specialists such as Nerophis, Ophidion and Syngnathus tenionotus provides more sensitive information on habitat quality rather than the presence of generalist species such as Syngnathus sabaster and also Syngnathus stifle. So from these findings, we can, and I'm finishing, we can from a conservation perspective, we have three implications. The first one is that monitoring should move from beyond present substance data and incorporate other metrics such as density, which better capture habitat quality and ecological functioning. Second, maintaining and restoring continuous macrophyte should be even a priority, and conservation targets should be calibrated to the intrinsic ecological potential of each lagoon. So I finished. Thank you for the attention. And